Hello dear students, in this video I'll continue with the 7th unit Financial Mathematics. In this video we will learn about the next topic in 7th unit, which is EMI. It stands for Equated Monthly Installments. Here we will learn about how we can calculate EMI using flat rate method and reducing balance method. We will also see the questions from exercise 7.3 of CBSE Handbook. And now before seeing the formula for EMI, we will see some of the basic terms related to EMI. Each of these terms we are all familiar. Now let us just have a recap of all these terms. The first one is principal. Principal is the initial amount of money that is being borrowed or invested, or it is the amount of money for which loan is taken in this context. And next we have interest. Interest is the price which is paid by a borrower for the use of lender's money. So the amount that the borrower has to pay for using the lender's money is interest. It is the difference between initial amount borrowed and the end payment which is made. And next we have the rate of interest. Rate of interest is the percentage of this principal, or it is the percentage of sum borrowed which is charged for a definite length of time. And next we have term of loan. Now this term of loan is nothing but it is the defined length of time within which the borrower has to repay the entire amount to the lender. It is the defined length of time it will take for a loan to be completely paid off when the borrower is making regular payments. So these are some of the terms related to equated monthly installments. Now we will see EMI. EMI, as I already mentioned, it stands for equated monthly installment. It is a monthly payment that has to be made towards a loan that is opted for at a fixed date of every month. So we have to pay a monthly payment for a loan which we have taken at a fixed date of every month. That is EMI. The amount for which we take loan, it is called the amortized amount. We say a loan can be amortized if it can be discharged by a sequence of equal payments. Now this sequence of equal payments is nothing but it is EMI that is made over equal periods of time, that is every month. Now each payment can be considered as consisting of two parts. One is interest on the outstanding loan and repayment of part of the loan. Now let us understand this EMI with an example. Say for example, if a person has opted for a loan for rupees 1 lakh, the interest is 8% compounded monthly, and this 1 lakh has to be repaid in 1 year by way of equated monthly installments for 12 months. So here this is known as the loan amortization schedule. So here every month he has to pay an EMI of rupees 8,792. This is EMI. So here we can see that each month's EMI, it has two parts. One is the principal and the other one is the interest. So here we can see that each payment can be considered as consisting of two parts. One is interest on the outstanding loan and repayment of part of the loan. So like that, over a period of 1 year, that is over a period of 12 months, the principal is repaid along with the interest, so that at the end of the year, the total loan amount along with the interest is repaid, so that at the end of the year, the balance to be paid is 0. So this is how EMI works. Now we will see the two types of calculation of EMI or installment. The first one is called the flat rate method. In this flat rate method, each interest charge is calculated based on the original loan amount. So the interest is calculated on the original amount, although every year the loan balance is getting reduced. In this flat rate method, interest is calculated based on the original loan amount itself. So if we consider the principal of the loan as P, the total interest on the principal as I, and N as the number of months in the loan period, then EMI is given by the formula EMI, it is usually denoted by R. It is given by P plus I upon N. So this is the formula to find the equated monthly installments in case of flat rate method. Here the interest is charged on this original loan amount. It is charged on this principal amount itself every year. Although every year the loan balance is gradually reducing, the total, the interest is calculated on this principal amount itself. So this is the formula. This is a very easy formula. The next method which is used to calculate EMI is the reducing balance method. According to this method, if a person is amortizing a loan at the beginning of any period, the principal outstanding is the present value of remaining payments. So this reducing balance method, it is done based on this concept. The principal outstanding is the present value of the remaining payments. The other features of this method include the outstanding principal amount, it decreases with every EMI, and the interest for every EMI is calculated on the outstanding principal. So if we see the example that we just now saw, then we will be able to understand this in a better way. So if the loan amount is rupees 1 lakh and the interest is 8% compounded monthly, which has to be repaid in 1 year by 12 equated monthly installments, then the equated monthly installment amount is 8,792. Now the principal at the beginning of any period, this 1 lakh, it is nothing but it is the present value of these payments. So that is the meaning of this line. At the beginning of any period, the principal outstanding is the present value of remaining payments. So if we see this 1 lakh will be the present value of these payments. And then here it is given outstanding principal amount decreases with every EMI. So this is the outstanding principal amount. Outstanding principal is nothing but the principal that has to be repaid or the remaining principal. So here we can see that at the end of the first month, the principal has reduced to 292,042 and so on. It keeps on reducing until it reaches 0. And then next point about this method is interest for every EMI is calculated on the outstanding principal. So the interest for every EMI, it is calculated based on the outstanding principal. So these are the features of reducing balance method. And next we have the reducing balance method or amortization formulas. We can calculate EMI as I already mentioned using two methods. The first one is the flat rate method which we just now saw, and the other one is the reducing balance method. So here the periodic payment or the installment, it is calculated based on R is equal to P upon A at an angle of N for I rate per period. So the EMI is calculated as the principal upon A at an angle of N for I rate per period. This is nothing but it is the present value annuity factor. This is calculated as 1 minus 1 plus I the whole raised to minus N upon I, or it is P into I upon 1 minus 1 plus I the whole raised to minus N, the reciprocal of this, where P is the amount of loan, I is the rate per period, and N is the number of equal payments. So this is the formula we have to use if we are asked to calculate EMI using reducing balance method. And the next formula is if we want to calculate the principal outstanding at the beginning of kth period. If we are asked to find the principal that is outstanding at the beginning of kth period. Say for example, if the loan is for 10 years and we are asked to find the principal at the beginning of second year. So like that, if we are asked a question like that, then we can use this formula. This is calculated as R into A at an angle of N minus K plus 1 for I rate per period. So this is the formula to find the principal outstanding at the beginning of kth period. A at an angle of N for I rate per period, this is the formula. So if we have n minus k plus 1, then the formula will be 1 minus 1 plus I the whole raised to minus n plus k minus 1 upon I. So using this formula, we can find the principal outstanding at the beginning of kth period. And next we have the formula for finding total interest paid. The total interest paid, we are paying this EMI of rupees R every month for n number of equal payments. So the total interest amount will be n into R. Now this n into R, it consists of both the principal and the interest. So if we reduce the principal from this, we will be able to find the total interest paid. So the total interest paid, it is calculated as this n into R minus P. If we have n into R, R which is EMI, it consists of both principal and the interest. So if we subtract principal from this amount, we will find the total interest paid. So here P is the amount of loan, R is the size of equal payment or EMI, I is the rate per period, and N is the number of equal payments. So we have to use this formula when we are asked to find EMI using reducing balance method. To find total interest paid, this formula is used. Usually questions on EMI using reducing balance method can be expected for 3 marks. Now we will move on to questions from exercise 7.3. Mohan takes a loan of rupees 5 lakhs with 8% annual interest rate for 6 years. Calculate EMI under flat rate system. So here it is given Mohan takes a loan of rupees 5 lakhs. So this is the principal P with 8% annual interest rate and for 6 years. So this is the rate of interest and the time period is 6 years. We have to find the equated monthly installment under flat rate system. So we have to remember what is asked and accordingly we have to find the answer. First let us write what is given. P is rupees 5 lakhs. N is 6 years. Number of payments will be 6 into 12, 72. For finding EMI using flat rate system, we need to know the total interest, capital I. Total interest is 8 by 100 into 5 lakhs. This is the yearly interest. Total interest will be the interest for 6 years. So, into 6. So, this is 8 by 100 into 5 lakhs into 6 will be the total interest. So, it is rupees 2,40,000. Under flat rate system, EMI equal to P plus I upon N, or P is 5 lakhs plus I is 2,40,000 upon N is 72. It is 7,40,000 upon 72. Now this when we simplify we get it as 10,277.7. Therefore, EMI equal to rupees 10,278. So this much is the EMI if it is calculated using flat rate system. Next we have the next question. XYZ company borrows rupees 3 lakhs with 7% annual interest rate for 4 years. Calculate EMI under reducing balance method. So here we have to find EMI using reducing balance method. So first let us write what is given. P is rupees 3 lakhs. I is 7%. Under reducing balance method, the interest is compounded monthly. So it is 7% by 12. It is 0.07 by 12, which is 0.00583. N is 4 years. So 4 into 12. Since the payments are made every month, it is 48. Now we have the formula. EMI R equal to P upon A at an angle N for I rate per period. It is P into I upon 1 minus 1 plus I the whole raised to minus N. When we substitute each of these values, we will get the answer. P is 3 lakhs. I is 0.00583 upon 1 minus 1 plus 0.00583 the whole raised to minus 48. Now this 3 lakhs into 0.00583, it is 1749 upon 1 minus 1.00583 the whole raised to minus 48 is 0.7564. 0.7564. So EMI is 1749 upon 0.2436. Now this when we divide, we get it as 7179.8. Therefore, EMI equal to rupees 7179.8. Similar question can be expected for 3 marks. Writing what is given carries 1 mark. Then writing the formula for EMI, substituting the values and getting the final answer according to what is asked in the question will carry 2 marks. So a total of 3 marks for such questions. Moving on to the next question. Rajesh borrows rupees 6 lakhs with 9% annual interest rate for 5 years. Calculate EMI under reducing balance method. So it is similar to the previous question. Everything is given directly. The amount that is borrowed, this is the principal P. Annual interest rate is 9%. So we have to find I by compounding it monthly. And then N will be 5 years. That is 5 into 12. Given P equal to rupees 6 lakhs. I equal to 9% by 12. It is 0.09 by 12, which is 0.0075. Then N is 5 into 12, 60. Now we can find EMI. EMI R is equal to P upon A at an angle N for I rate per period. It is P into I upon 1 minus 1 plus I the whole raised to minus N. P is 6 lakhs. I is 0.0075 upon 1 minus 1 plus 0.0075 the whole raised to minus 60. N is 60. Now if we substitute for 1.0075 whole raised to minus 60 here and simplify, we will find the answer for EMI or R. Now 6 lakhs into 0.0075, it is 4,500 upon 1 minus 0.6387. 1.0075 whole raised to minus 60 is 0.6387. So this is 4,500 upon 0.3613. Now this when we simplify, we get it as 12,455. Therefore, EMI equal to rupees 12,455. This is the answer. Moving on to the next question. A person amortizes a loan of rupees 1,50,000 for a new home by obtaining a 10-year mortgage at the rate of 12% compounded monthly. Find the monthly payments, total interest paid. So the amortized amount is given, it is 1,50,000 and the time period is 10 years. So number of periods will be 10 into 12, 120. And then the rate of interest is given, it is 12% compounded monthly. So I will be 12% by 12. Using all these, we can find the monthly payments, that is the EMI, and we can find the total interest paid. Given P is rupees 1,50,000, I is 12% upon 12, it is 0.12 by 12, which is 0.01. Then N is, it is 10 years, so the number of payments will be 10 into 12, 120. So EMI R is equal to P upon A at an angle N for I rate per period. I'm just writing the formula so that it will be easy, because in the sample paper the value for 1 plus I the whole raised to minus n is only given. So at that time we can use only this formula. But here we have A at an angle of 120 for 0.01 rate is given. So let us use this formula. So this is equal to P is 1,50,000 upon A at an angle of 120 for 0.01 rate per period. So this is given as 69.6891. So it is 1,50,000 upon 69.6891. So this, when we simplify, we get it as EMI equal to 2,152.42. So EMI equal to rupees 2,152.42. This is the first subdivision. The first subdivision, they have asked the monthly payments, that is the EMI. EMI we got the answer as 2,152.42. Now we need to find the total interest paid. Second subdivision, total interest paid. We know how it can be calculated. It is calculated as N into R minus P. So here N is 120 into R is this EMI, 2,152.42 minus P is 1,50,000. So this, when we simplify, 2,58,290.4 minus 1,50,000. When we subtract, we get 1,08,290.4 rupees. So this much is the total interest paid. Last question. A couple wishes to purchase a house for rupees 12 lakhs with a down payment of rupees 2,50,000. If they can amortize the balance at 9% per annum, compounded monthly for 20 years, what is their monthly payment in rupees? What is the total interest paid? So here it is given, a couple wishes to purchase a house for rupees 12 lakhs and they are making a down payment of rupees 2,50,000. So the amortized amount or the amount for which loan is taken will be the difference between these two amounts. They are amortizing the balance at 9% per annum compounded monthly for 20 years. So let us find the monthly payment. So first, so here cost of the house is given, rupees 12 lakhs, and then down payment is given. rupees 2,50,000. So the amortized amount will be the difference between these two. 12 lakh minus 2,50,000. So it is 9,50,000. This much is the amortized amount. And next we have interest. Interest is 9% per annum compounded monthly. So it is 9% by 12. It is 0.09 by 12, which is 0.0075. And then N is 20 years. So number of payments will be 20 into 12, 240. First, let us find the first subdivision. EMI R is equal to P upon A at an angle of N for I rate per period. So P is this amount, 9,50,000 upon A at an angle of N is 240 and I is 0.0075. Now this value they have given here. So it is 9,50,000 upon 111.1449. This when we simplify, we get it as 8,547.4. Therefore, EMI equal to rupees 8,547.4. Now let us find the total interest paid. Total interest paid. It will be N into R minus P. So N is 240, R is 8,547.4 minus P is 9,50,000. 240 into 8,547.4 minus 9,50,000. So this is 20,51,376 minus 9,50,000. Now this when we subtract, we get it as 11,01,376 rupees. So this much is the total interest paid for 9,50,000. So if an additional question is asked, what is the total interest paid? That will carry 1 mark. So finding the total interest paid will have 1 mark. I hope this video was useful for you. In my next video, I'll solve a question on using the formula for finding the principal outstanding at the beginning of kth period. If you have not subscribed to my channel, please subscribe. Thank you for watching.